Let's talk about biological evolution as a physical process. I'm planning to I'm planning to prepare a series of videos on a connection between quantum mechanics and the biological evolution. So this will be the first one. So let's begin. Let's begin with a story. Basically, let's go. Uh, let's go with an argument. Imagine a river flowing down a mountain. Now, this river does not decide where to go. It does not plan its path. You have a river, it's flowing, it's not deciding anything. Yet, its motion, its motion is not accidental. The river, it flows. The river flows because because of gravity, and its curves are shaped by the hardness of the rock with which this river interacts. Its speed is controlled. Its speed is controlled by the slope of the land. You have more slope, the speed is more. You have less slope, the speed is less. So what does it mean? It means water follows laws. The landscape, this landscape sets the constraints to the flow of this river. And within those constraints, there are countless paths possible. There are objections, but the paths that are possible, they are very large. Now, biological evolution. The biological evolution is like that river that I was trying to describe. I was telling you to imagine. It is not guided by the intention, but at the same point of time, it's never accidental in nature. It flows, it flows within laws, and those laws are physical in nature. There are physical contacts that are leading this water, that are leading this river to flow. Now, now imagine holding a single living cell in your hand. I have a living cell in my hand. Now, inside this cell, inside the cell, nothing is random. There's no chaos. Within this cell, molecules move. Within this cell, energy flows, and the information is copied. And when the information is copied, the structures are assembled. The structures assemble and disassemble. So we cannot imagine a cell working on random principles. Every step within this cell follows a physical rule, a rule of interaction, a rule of replication. Now, that single cell belongs to a chain of stretching back billions of years each. The billions of years each generation connected to the next step. Now, each change is constrained. Each change is constrained by what matter allows. So, this long, lawful transformation of life is what we call as biological cell, the evolution of biology of the cells. This is the point of contention. This is the point of motivation. So, what am I trying to do here is I'm trying to make a statement using quantum mechanics of biological evolution. And this is the target that I'm trying to share with you. I'm trying to explore. I'm trying to understand with you. Biological evolution is a physical process. It is not accidental. If the flow of the river is not accidental, then how come the biology of a cell can be accidental in nature? It's not mystical in nature at the same point of time. Life is made of ordinary matter. It's made of ordinary atoms. It's made of ordinary constituents that belong to this universe. Now let me go with another story here, because I want to understand the argument. I want to realize it. So let's assume that we are building a house. You are building a house, and you may design different shapes. You may choose a different layouts. You are planning to build a house. You are choosing different layouts. You are choosing different geometries. But you must obey the properties of bricks. You cannot do anything that you want. You have to obey the properties of the steel that you're using in your house. You have to obey the properties of the wood that you are making use in your house. You cannot build a floating wall. You cannot place a load where material cannot support. The material cannot hold. The material cannot support that load. So we are coming to the architecture. So architecture is creative, but at the same time there are constraints in that architecture that are because of the material that we have been using in building this house. And I believe the life works the same way. Living organisms. If you think about the living organisms feel extraordinary. They feel extremely extraordinary. But they are built from ordinary atoms. Their basic bones are the ordinary atoms. The atoms like carbon, hydrogen, oxygen, nitrogen. These are the basic building blocks of the organisms which are feeling that they are extraordinary, but they are coming from the same atoms found in soil, the same atoms found in oceans, the same atoms that are found in stars. Now, these atoms, they obey the same laws, they obey the same constraints, they obey the same laws everywhere. Now, now, what makes life remarkable is not the new matter because it has the same matter. It is the organization in which the matter is moving on under these constraints, the constraints of the river. Now, once we understand this biological evolution clearly, it clearly belongs to science, and it seems to be the heart of physics. It seems to be the nerve of physics. It seems to be something physics. Now, what biology explains us, I'm not an expert of biology, but as long as we understand what biology teaches us, what it does, it assumes that what biology tells us is how, if I can put it like this, how populations change, how the populations keep on changing over generations and generations. This is how biology works. And you have different individuals. So individuals differ. Some differences are inherited over the long periods, and there is change in the population. So populations change. So this description works. It works beautifully. It explains us the diversity. It explains us the various domains of biological evolution. But the biology that we are talking about, it quietly assumes something deeper, something more deep, that molecules can store information, that this information that the molecules can store, this information can be copied. And that copying is reliable. It's exactly copied with a very, very minimum error, but not perfect. So these are not biological miracles. They are physical achievements. These are the achievements of these molecules. These are the achievements of these molecules over millions of years. DNA is not an idea. It's a matter. It's a matter of being made of these basic constituents that are ordinarily available everywhere. So when DNA changes, it is not an accident. How can we treat this an accident? It's a physical event happening over millions of years. And this event is going on and on. Think about a bond. A bond shifts. An energy barrier is crossed. A configuration changes. If there is the tunneling of the particles within the DNA. So biology names the consequence. And what about the physics? What about physics? Physics governs the possibility because it tackles down the laws that are governing these fundamental particles to be there. Now, let's talk about the staircase of scales. The scales. Now, assume, or maybe now consider a staircase. Let's assume that we have a staircase, and at the top of the staircase, you see ecosystems, you see species, and below that, you see organisms, and below that, you see cells, and below that, you see molecules, and below that, what do you see? You see atoms. So there is a staircase. It's coming from that complexity to the atoms. And you cannot skip the steps. At every step, there is something. Now, each level rests on the one below it. It's a perfect staircase that I'm telling you to imagine at the top and at the bottom, taking down into atoms only. The higher levels, classical ideas work at the higher levels. We talk about growth, we talk about competition, we talk about survival. These are classical results. But as we descend from this staircase, as we descend, intuition fades. It goes on fading. And at molecular scales, matter follows quantum mechanics. Matter follows quantum rules. Matter follows Schrodinger's wave equation. Proteins. There are protein shapes. There is genetic stability. There are chemical reaction. There are chemical reaction efficiency. All of these things that we talk about at the classical level, they are all emerging from the quantum behavior. They're all coming from that microscopic particle. Now, life itself does not behave quantum mechanically, but life is built from the quantum mechanical laws. Life is built from quantum governed matter. The matter that's governed by the probabilities, the matter that can tunnel, the matter that can be at many points at the same point of time. Now, why classical physics is not enough to realize this phenomenon? The classical physics explains motion and force. Okay, you have the motion of the objects, you apply the force, there's motion, the Newton's laws. It explains how muscles move. It explains how blood flows in our arteries and veins. And it explains how organisms interact with their environment. Classical physics can explain this level of interaction. But this is classical. But classical physics cannot. The classical physics cannot explain you the bottom of that staircase. And what is at the bottom of that staircase is atoms. It cannot explain you why atoms do not collapse. It cannot explain you why molecules have some specific shapes, some specific frameworks. It cannot explain you why chemistry at the atomic and molecular level works at all. What I've been trying to tell you is that without quantum mechanics, there is no stable atom. Without quantum mechanics, there is no complex molecule. Without quantum mechanics, there is no deoxyribose nucleic acid, what we call as DNA. So when we speak about evolution, quantum mechanics is not an additional detail of the evolution that we are trying to frame here. It's not going to add something. It is the silent foundation. It is the silent base. It is the silent basic constituents of life, of evolution. Now, quantum mechanics is not a kind of lottery here. You're not saying, come on, this is quantum mechanics and you are going to get it exactly. No, it's not like that. It's something that's giving you a foundation. And here we must be very clear. We must be very realizing that quantum mechanics is often misunderstood as pure randomness. No, it's not the pure randomness. No, it's not. It is not a lottery. No, it is not the randomness at all. It's something filled with possibilities. So quantum mechanics is basically a law governed theory. It defines which states are allowed and which states are not allowed, which transitions are allowed and which transitions are not allowed, which transitions are possible and which transitions are impossible. So it tells us how probabilities are structured in the realm of this universe. Nothing happens outside these rules as long as the physicality of the rule is concerned. Even quantum uncertainty, what has the base of Heisenberg uncertainty principle. It has a structure. It has a framework. It's something that guards it. So when quantum events influence biology, nothing is accidental. It's a wrong argument. It's a wrong statement. It's a wrong realization. They are lawful possibilities being explored within the framework of that structure. Randomness is randomness. But what's embedded in that randomness is the discipline. So it's randomness with discipline. I'm trying to bore you more. Now consider another story. Let's take another story here and imagine Imagine throwing a seed into a field. Okay, I have a seed and I throw it on the field. And the seeds, assuming to be seeds, okay, where they land is unpredictable. But whether they grow, it depends on the soil, it depends on the water, it depends on the fertility of that land, it depends on the radiations that are coming from sun. So you randomly placed. So random placement, but there are strict constraints that are going to make this process happen. And it feels like life works the same way. There are constraints, there are laws, there are possibilities, and quantum events, they introduce variations. They introduce the variations in the systems. So what about the biology? The biology filters those variations. It filters them into the classical models. And most of the changes disappear. And some of the changes persist. A few shape the future. They are governed to shape the future. The point is, they shape. So variation is not chaos. It is disciplined by physical and biological laws. It has its bones, it has its basis in those disciplined laws. So evolution, if we explore it, it's an exploration. It is not accidental. Evolution is not accidental. Evolution is often described as chance, but that's not the case. This is perhaps misleading us. This is misleading our understanding. Evolution is an exploration within the constraints. These atoms are exploring. They are trained over billions of years to replicate themselves, like a river, like the architecture, like the seed that I talked about, the seeds that we drop on the field. What do you have? You have many forms of life, and many forms of life never appear, not because they are rejected, but because they are impossible. They cannot make it. They cannot do it. The forms that exist satisfy many laws, and they satisfy at once. So, quantum mechanics, what it does, it defines the smallest building blocks of that staircase that I was talking about. The smallest building blocks of this landscape that we are talking about. And evolution explores. Evolution explores it over immense time, over billions of years, over millions of years. It explores all of these possibilities over long, long time. So in future, I'll be making the videos on the same concept, and let's take the different frameworks to understand the same thing. And we would try to understand that how quantum mechanics supports the material foundation of the biological evolution. That will be our target. That will be something that I will try to pass on, and I think that's equally very important to be inserted in the set of these videos in which I'll be talking about. I'll try to manage to understand basically that how it works, and how quantum mechanics has a lot to do with evolution. So what we have a purpose here. We have a purpose to understand the science of it, and we have a purpose to understand the meaning of it. In fact, these things are not going to predict something. They're not going to predict the outcomes, but that will be something that we will try to understand. We'll try to look on, and and that is the target. I hope you like it, uh, and from here we will go into the next important video concerning our title. The title is basically the quantum mechanics and evolution, or you can say the quantum mechanics of evolution, or you can say the guidance of quantum mechanics to learn the evolution. And I think the examples that I came up with, the example of the flow of a river, the example of a staircase, the stories that I tried to share with you to understand the concept, I think they will make an impression for us to understand what we have tried to pass on. Okay, so with this, I would like to stop here. I wish you good luck, and let's hope that I succeed in making further videos on the same topic that